A black hole just formed, 1 light-year away from Earth. Right now. You can't see it. No telescope on Earth has detected it yet. No government has issued a warning. Your phone hasn't buzzed. The sky outside looks exactly the same as it did this morning. But 1 light-year away from where you're sitting, a black hole just formed. And it is already, slowly, invisibly, inevitably, pulling everything toward it, including us. Before we get into what happens to us, let's be clear about what we're actually dealing with. A black hole isn't a hole. It isn't empty space. It is the most extreme concentration of mass that physics allows to exist. When a star massive enough, roughly 20 times the mass of our sun or more, reaches the end of its life, it collapses inward under its own gravity. In a fraction of a second, something that was millions of kilometers across compresses down to a single point called a singularity. A point with no volume, but infinite density. And surrounding that singularity is the event horizon, the point of no return, the boundary where gravity becomes so strong that not even light, traveling at 186,000 miles per second, can escape. Once light can't get out, you can't see it. That's why black holes are black. Now, the one that just appeared 1 light-year away from Earth. 1 light-year sounds like a lot. It's about 5.9 trillion miles. It took the Voyager spacecraft, the fastest object humanity has ever launched, 35 years to travel just 1 light-year. But in gravitational terms, 1 light-year is nothing. It is dangerously, catastrophically close. Here's where it gets unsettling. Gravity travels at the speed of light. That means the gravitational effects of this black hole, 1 light-year away, will reach Earth in exactly 1 year. Not immediately. Not in 1,000 years. 1 year. In 12 months, Earth will begin to feel a gravitational tug it has never felt before in its 4.5 billion-year history. And here's the terrifying part. There is nothing we can do about that. The warning arrived at the same time as the effect. Gravity and light travel at the same speed. By the time any telescope detects this black hole, by the time any scientist confirms it is real, Earth is already being pulled. The question isn't whether it's coming. The question is, what happens when it arrives? But first, for 1 year, everything looks completely normal. Life goes on. Seasons change. People go to work, fall in love, make plans for the future. All while something is racing toward us at the speed of light. Before we dive into the countdown to year 1, we're on a mission to reach our first 100 explorers on this channel. If you find the vastness of the cosmos as terrifying and beautiful as we do, join us. Hit that subscribe button and let's reach this milestone together. Now, year 1 arrives. The first effects are subtle. So subtle that only the most sensitive instruments on Earth would detect them. Tiny variations in Earth's orbit, fractions of a millimeter per day. The kind of thing that requires atomic clocks and space-based observatories to measure. But it accumulates. By month 3 of year 1, the variations become measurable without specialized equipment. Astronomers notice that something is pulling on the outer planets, Neptune, Uranus, more strongly than calculations predict. The scientific community goes into emergency mode. Governments are briefed, and then the public finds out. What happens next depends entirely on the distance and mass of the black hole. For a black hole that formed from a standard stellar collapse, around 10 to 30 solar masses, at 1 light-year distance, the gravitational effect on Earth is significant, but not immediately catastrophic. It's pulling us, yes, but slowly, Think of it like a drain in a bathtub. You're not immediately sucked in. You circle and circle, and the circles get tighter and faster. And the process takes not years, but centuries, maybe millennia, unless this black hole is bigger. Much bigger, but let's say it's a supermassive one. Or let's say that even with a stellar mass black hole, enough time passes that an Earth's orbit has decayed to the point of no return. What happens in the final approach is one of the most bizarre phenomena in all of physics. Scientists call it spaghettification. As an object gets close enough to a black hole, the difference in gravitational pull between the near side and the far side becomes extreme. The side of Earth facing the black hole is being pulled enormously harder than the side facing away. This difference, called tidal force, stretches whatever is in its grip into a long, thin strand, like spaghetti. First, the atmosphere would be stripped, then the oceans, then the mantle, then the core. Not in an explosion, there is no explosion. Just a slow, silent, inevitable stretching. Earth would be unraveled like a thread being pulled from a sweater, atom by atom, molecule by molecule, drawn into an impossibly thin stream of matter flowing directly into the singularity. Everything that ever existed on this planet, every civilization, every ocean, every mountain, reduced to a stream of particles thinner than a human hair, falling forever into a point of infinite density, in complete silence. Here's the one question that matters. Could we actually detect it in time to do anything? The answer is complicated. We have gravitational wave detectors, instruments like LIGO in the United States and Virgo in Europe, sensitive enough to detect the ripples in space-time caused by black hole mergers billions of light years away. A black hole forming just 1 light year from Earth would produce gravitational waves so powerful they would be unmistakable. We would know the instant it formed. But knowing and doing something about it are very different things. There is no spacecraft fast enough. There is no technology that could deflect a black hole. There is no planet we could reach in time. The honest truth is that if a black hole appeared 1 light year away, our only response would be to watch, to measure, to understand, and to know with mathematical certainty what was coming. In that way, it's the purest version of humanity's relationship with the universe. We are observers, brilliant, curious, inventive observers who built telescopes and equations and space missions, but observers nonetheless, of a cosmos that operates entirely on its own terms. There are roughly 1 billion black holes in the Milky Way alone. 1 billion. Most of them are drifting through the galaxy right now, silent and invisible, detectable only by their effect on the light and matter around them. The nearest known black hole to Earth, Gaia BH1, is about 1,500 light years away. Safe for now. But the galaxy is not static. Stars move. Black holes wander. The odds of one appearing at 1 light-year distance in any given human lifetime are extraordinarily small. And yet the universe has been here for 13.8 billion years, and it will be here for trillions more. In that timescale, extraordinary things, things that seem impossible from where we stand, happen routinely. We exist in a brief, improbable window of calm, a moment in cosmic history where the nearest catastrophe is far enough away that we can look at the stars with wonder instead of terror. Don't waste it. See you in the next one.